Hello. Hey, welcome back. Man, it is great to connect with you again. How are you guys doing? That's a super important question to know, and hopefully it's going well for you. Hopefully you're ready for a great lecture series today. I mean, we got a great topic today. As you can see there, DNA replication. Excuse me. DNA replication. I mean, top 10 important topics if you're ever gonna make a list of biology based topics. This has got to be way up there. Of course, I don't know how you would ever list. I mean, they're all so super important, and we couldn't get by without any of them. And but anyway, it's great to connect with you guys again. Oh man, two things I gotta fix from last time. Not the information. You know, my information is flawless and perfect. You know that. But just little goofs on my part. Well, not really a goof because the second one, I just didn't imagine it. But I mentioned last time that this would be a two-part video. It's actually going to be three. Once I developed the presentation, and of course my lectures are so wonderful, we're going to call them presentations. That actually the second one would have been super long, maybe even an hour and a half. I don't know. That's way too long. So we cut that one in half, and so this one will be about DNA replication and the cell cycle, as you can see down here. And then the next time that you watch one of these over chapter, A&P's chapter 4, the third one will be over genetics. And the reason why I broke that one up is the genetics is a lot of vocab, and I want to I'll be typing it so it's everything's clear. So, and now it's going to take me forever, and you know that. So we'll break that one into a third. The second thing I got to fix is, man, I left out. I wasn't even thinking when I did my introduction yesterday that the bio people will be watching this as well. I completely left them out. I just focused on A and P. So I apologize to the bio people, but again, welcome. So I see you, Nevada High School students, biology, whether you're dual credit or not. Hey, I see you, Crowder bio students, and of course the A&P, who this was originally designed for. I see you guys as well, both at the high school and at Crowder on a Monday or Wednesday night. So looking forward to this. It's going to be some great stuff, and especially the next time we get into genetics, and we're going to be doing Punnett squares. Ooh, I love me some Punnett squares. I can Punnett square myself to death if the students are interested. I love doing that stuff, and of course it answers the classic old question of how can parents with brown hair produce that beautiful blue-eyed blonde-haired baby girl. And but we'll get into all that in time. Again, that's next video, so that's not even today's. So let's get started. Man, we're going to jump right into it. Big time right here, hot and heavy. This picture, I can't decide. Do I want to go bigger and bring it down and talk about it? No, I better keep it small because I got a lot to put on the screen here. So let me put this back up here. Man, look at all those skills I got. I'm zooming in, zooming out. I'm moving left and right. It's all going good right now. And it's, don't tell my wife this, but I was working on Labor Day morning, so she thinks, I don't know. Anyway. So yeah, Labor Day morning, getting this done, so I can enjoy the rest of the day. Got some good stuff planned. Man, the grill is going to be producing some good stuff. Let me just say that. Or in this case, since you're watching the post, I should have said the grill did produce some good stuff. All right, but let's get going here. So we've got this picture of DNA replication. Okay, and some things that we want to say right off the bat is that, let me get a little pen here. What would be a good color for DNA replication? You know what? It's a holiday. So let's just go all out. Let's do something super fantastic. Oh yeah, look at that right there. Let's get maybe a little bit thinner though. What's this one look like? That's not bad. if I need to be thinner, we'll take care of that. But the first thing you want to pay attention to is arrows. Arrows here, arrows here, okay, arrows here, because the two strands are duplicated in opposite directions. But we'll get to all that in time. Okay, the first thing, and let me think. No, I'll be okay. Just writing it with the mouse. Okay, so the first thing we want to talk about is histones, and I'm already regretting the thickness of that. So let's go all the way down here. And I'm already regretting not typing this, but I'm old school. All right, histones. That's supposed to be all one word there. Histones are those things that the DNA is wrapped around. We've talked about how proteins and DNA are kind of packaged and coiled around and enough to make them to where they're compact. So the first thing that happens, you got to unpack them. You got to roll them out. You got to make them where they're nice and just long strands. So they unwrap around all those histones. That's the first thing that has to happen. Okay. Then what happens next is this bad boy right here, the DNA heliocase. And what he does is, I don't want to use the word opens, but he separates. That's the word I want. He separates, and I shouldn't say he. Separates. I'm going to start typing this. That's bad. It separates the DNA strands, so the polymerases can come in and get to work. With the DNA heliocase, it comes along and separates the two strands and gets them all cleaned up, gets them ready to go, and everything like that. Now this section here, and this is kind of important because this kind of sets the directional stuff. But this opening between the two, that's called the replication fork, and that's not a thing other than just a reference to the fact that where the DNA is separate from each other, where it's been opened up, that's the replication fork, and the polymerases on one strand move towards it, the polymerases on the other strand move away from it. But we'll get into all of that. So the next entity we want to talk about is these big green things. These are the polymerases, and they're the ones that are building. We talked about those complementary base pairs. Those complementary base pairs, we've talked about that. And so these polymerases attach to the older DNA strand, and they just move along the strand, and they're just matching up complementary base pairs. If they read an A, they put a T on the opposite side. If they read a C, they put a G on the opposite side. If they read an A, they put a T on the opposite side. And if they read a, which one I think I said, so if they put a G, they put a C on the opposite side. They're just building as they go. And of course, they're also making those, sugar phosphate side rails as well. So you can see that this is the former, the one they're reading, and you can see that not only they've mentioned the nucleotides, they're also building those sugar phosphate side rails as well that we learned about last time. So that's the polymerases. Now, these different strands have names. This one, the one in which the polymerases go towards the replication fork, that's called the leading strand. And I guess I should keep talking. That's the leading strand, and I'm just going to put the one word, but also just recognize it should say strand, and that's supposed to be an A. This is the lagging strand. Now, I'm not going to profess to know all the super deep details about why, but I'm just telling you what's going on. Okay, why they go in opposite directions, I'm not 100% knowledgeable about that. Probably should be. Maybe that's a weekend project. But the idea is the leading strand, they move towards the replication fork, and the lagging strand, they move away from the replication fork. Now you can also see, look down here. The next thing to mention is this ligase. Now the ligases, they're on the lagging strand. That's why you see one here, you don't see one up here. Because what's happening is that on the lagging strand, okay, you've got thousands of polymerases that are on this lagging strand and building these DNA strands in sections. Okay, so like they'll come along, like they're all working at the same time. So say we were building a railroad track, instead of having one crew go one beam at a time and just working their way across and take years to put a railroad track down. Imagine if we had 1,000 teams, each working on 100 feet, and then when they get their 100 feet made, then they jump ahead to wherever the next spot where there's no railroad tracks. In other words, like the team in the back would go ahead of the team in the front, and then they would sit, and you would take from yourself, and you'd go up to the front of the line, and when you finish your 100 feet, you go to the 100 line. That's what these polymerases are doing. They'll read along a particular length of a section, and then they'll jump off and go to the front of the line and continue reading. This way, it gets it done in a much quicker. It would take weeks for one polymerase to go down the strand and do it all by itself. But then when they're doing that, also imagine on these railroad tracks that there was one particular crew that would come along and just kind of tidy up and finish each little section. You know, maybe there's a little gap, or they come along and just whatever they got to do to make sure that each section is smooth. And so when the train's coming down the track, there's no separation. There's nothing wrong with the track that would cause the train to have difficulties. That's what the ligases do. They come along and they kind of fill in these gaps. If there are gaps in replication, or maybe they don't make all the sugar phosphate wall, but the ligase's job is just to make sure each section is joined properly with the next section. That's what the ligases. So we're just gonna put they tidy up. Ooh, that was bad. They tidy up each of the sections, make sure everything is finalized and ready to go. Now, what you don't see is, so just a reminder that there are thousands of polymerases on this strand, lagging strand, to get this job done. But what you don't see is on the leading strand, the same thing is happening. They only got one here, but they are, again, it would take them a long time. So the polymerases on the lagging do short little sections. The polymerases on the leading do long strands, but there are a bunch of them on there doing it. They're just not one going down the whole thing. Again, it would take weeks to do so. So that is the ligase. And so when we finish, what we have here is what was one DNA strand with two, and now we have two DNA strands with both an old and new strand on it. So what that does is that continually just upgrades and keeps the DNA strands fresh. So they're always in good shape. And that's called semi-conservative And let me just type that. That's something that I would really make a mess of, just trying to with the pen. So semi and I think the word, yeah, replication goes after that. Semi-conservative replication, and I will move this up here, where get it off of there so you can see it. Semi-conservative replication, that's just the idea of each strand has an old and a new together. So the next time it gets read, you would just constantly be upgrading the DNA strand to have an old and new. So next time, when they get read again, what's considered new this time will be the old next time. And so the oldest strand is just last cycle's replication. So it's always fresh, keeps it updated. Now, while all this is going on, okay, in the cytoplasm, more histones are being made. Oh, I need my pen back. And I'll just put me a little line here. New histones are being made in the cytoplasm. And then once those are made, then they get delivered to where the nucleus will be. And I say will be, spoiler alert, at this particular time the nucleus has been dissolved. So all the things that need to work on the chromosomes can come in. But we'll talk about that once we get to the cell cycle down here. The cell cycle, and but we'll mention that again. But the histones are being made and delivered, and as soon as the replication is done, then they'll start wrapping around the strand again to be nice and concise. And really, then at that point, they're getting ready for prophase. But again, we'll talk about that once we get down there. And I mentioned it would take a long time. The polymerases can work about a pace about 100 base pairs per second. So if you can move along this and read 100 of the nucleotides per second, that's about the speed that they work. And the entire process of getting all of our chromosomes, remember we got 46, so that's a lot of polymerases going to work here. A lot of polymerases, and so it takes about 6 to 8 hours to get all this done. Okay, and then which will lead us into the cell cycle talk. But what you want to remember is that we have 46. So if they all get duplicated, we end up with 92. And you can get that, do the old school elementary times 2, carry the 1, 8, 9, 92. There you go. I was told there'd be no math, somebody's saying. Alright, so 6 to 8 hours, and so now you got 92 chromosomes, okay, which is not the right number, but hopefully you can envision why we need 92, because eventually, I've said everything, so I can close this and move this up and lead us into our next figure. We get into the cell cycle, we need 92, because eventually, once we get over here, and put my pen back up here, when we get to here and the cell divides, each cell will have the proper number of 46. And what I should have led with this, but hopefully this is all review. If you are someone who's fairly recent high school graduate, last 2, 3, 4, 5 years, you've gone through the EOC process, so you would have had this in your life science year in middle school. You would have had this in your regular biology class, and of course certainly your EOC situation. And if you're a dual credit person, so that if you're at high school, this is your third look at this, and hopefully it was just last year as a sophomore. But if you're a Crowder student, A&P or Bio 102, that again, this is your third, possibly fourth look at this stuff. So hopefully it's just a nice little review. But let's talk cell cycle. Now I am going to type here just so it's nice and neat. So what I'm going to do is I'm going to move this over just slightly. And of course that's our stuff we did last time. And let's pull up a little text box right here. I'm going to move it up here. And so now we're talking cell cycle. Alright, so you can see from our figure here, we've got the three main, or we've got four sections. You can't, these are pretty small, you can see these, but these are in your books, textbooks, no matter who you are. A&P, this is your picture, and then everybody else, A&P at the high school, and the two bio people, bio sets I should say, you won't have this exact picture, but you'll have one, and you certainly got it here. And it's this is too small to read, and that's a pretty textbooky phrase, but I am going to put everything right over here for you. So our first part, okay, the G1, that's this section right over here. Okay, G1 section. So you can see that it's a cycle. So once the cells divide, okay, they go right into the cycle again. So we've got the two cells here, one to give in the two, and then we go right into the G1 stage. And what's going on in the G1, and I should have let me put phase up here as well. All these are considered phases. Now we're ready. G1 phase. What's going on here? I'm going to put a little line here to emulate a outline format. Is we're gathering all the supplies. Okay, we're gathering all the supplies, and now I'm just going to move this over here just a bit so we can. Okay, so we're gathering all the supplies because we're building up for the next time we go through this process, and so all the things that we need, the nucleotides, just all the materials, everything, just whatever might be needed, it's being gathered all up. That is the G1 phase. Okay, the S phase. Now the S phase, with what we just talked about replication, that's when that happens. And you can kind of see DNA replication right there. So if you're ever somebody, I didn't do my fancy dash here in the beginning, so I'll put that right there. So if you're ever somewhere and just a conversation about cell cycle breaks out, and somebody's got the question, I know that DNA is replicated, but what part of the cell cycle does it happen? You will be ready to go, and you will raise your hand, and you will talk to your friend there and say, hey, S phase. Okay, that's the S phase is when that happens. Okay, so our next one, and it's hard to see, but this was G1, so this was sentimentally named G2 phase. And the G2 phase, proteins. All the proteins that these new chromosomes will need to help take care of them and support and whatever is needed for these new chromosome strands, the proteins are made. And I did it again, I forgot my little fancy line there. Hopefully you drew it on yours. You knew I was going to come back and get that. but the proteins are made, and any errors that may have occurred during the reading, so it's the polymerases are reading, and maybe they read A, but they put a C there by accident. Those will be fixed during the G2 phase. And then we got the M phase. And of course everybody knows this by its better name, mitosis. Okay? Incredible amount of stuff going here. I mean, when you think about what the cell is doing, okay, we wouldn't even, I know we consider cells living things, but what they do during even just everything, but this concept alone is simply amazing, that all this stuff knows what to do, when to do it, where to do it, how to do it, and we wouldn't think of them as being that, that kind of intelligent. They just know what to do, and it's absolutely amazing what's going on here. I know biology stuff isn't everybody's game plan, but I mean, the cool factor of what it does, how it does, when it does it, without any seemingly real brain, if you want to use it for whatever. But anyway, it's just amazing to me what it can do. Love talking about it. But mitosis. So, I mean, 4 phases, 5 phases, depends on how a person views cytokinesis. But you can see that cytokinesis is clearly in this diagram within the mitosis phase. But you can also, if you read any textbook, anything else, website, you may say 4, and then cytokinesis is kind of that transitionary phase. But for our purposes, we're going to say 5 phases. But do recognize, if you read somewhere else, they may say 4, and then cytokinesis happens after that. And we're going to get into each of those phases. Now there is, on rare occasions, oh no, that is the 0. There is a G0 phase. Okay, and this is the phase. This is the resting. This is the resting phase. Now, not every cell does this, and it isn't a phase that happens every time in this cycle. But on occasion, for whatever reason, the cell decides, hey, we just need to stop the process. Okay, maybe something's going wrong. Maybe the cell is damaged. Maybe the cell, it just went through the cell cycle and it didn't go well. Something bad has happened, and we're just going to shut her down until we can figure out what's going on. And if it's fixable, great, we'll fix it. And if it's not, then we'll just terminate. The cell terminates itself and goes in that. But just every once in a while, and again, this is supposed to be a 0. I know it looks like the word go, but remember that's a 0. Just like this was 1, this was 2, that's a 0. G0 phase. It's a resting phase. It's just a chance to kind of figure out what's going on and decide, okay, is this fixable, or do we just need to shut her down and terminate the cell? So that is your cell cycle. Okay, so let me get out of that. Now we're going to talk about, as our last topic, but we'll spend a little bit of time here. We'll be talking about mitosis. So let me bring this up. And of course, that down there, that starts the genetic stuff. That's a karyotype. Love me some karyotype. It's just so interesting. Lots of ways you can talk about that. But and actually, this one right over here, I set that up, use that, but we're not going to use that because I don't have one for the rest of them. So we will just push that off to the side, and we're going to try to bring this down. And again, this is a diagram of mitosis. And what I'm going to do first is just go over a quick overview, and then we will talk about each section individually, and I'll put up a little text box here, and we'll type it all so it's nice and neat. And mouth's getting a little dry there, so I got to take care of that. And so, but again, lots of words here, pretty textbooky definition, if that's a word. But we are going to talk about everything. But again, if you're an AP student at Crowder, this is in your book. And for the other 3 sections, you will have something like this in your textbook. It may not be exactly like this, but you'll certainly have these type of images. And then, you've got it here if nothing else. So, overview, mitosis. The idea is to, after the cells have, or the chromosomes have replicated, okay, now we got to prep everything for this massive display of power and cell division, where we go from 1 to 2. And so in the early days, after fertilization, and sorry you had to hear that, there's just one cell, and then that will divide into 2, 2 into 4, 4 into 8, and so on and so on. But and so through all those development years, from fertilization up to, a person is fully mature as far as height. So if we want to say, for some people, like me, it was early, 13, 14. I just shot up to the amazing height of 5'7" by the time I was, 12 and 13 years of age. So early on, okay, especially upper elementary, I remember in the 6th grade when it come basketball time, I was one of the taller ones because I got there so quickly, but then boom, plateaued or aka stopped at 5'7" and have lived the rest of my 70 years at that height. So, and that first year, through upper elementary, one of the taller kids that I mentioned, and that 6th grade year basketball, one of the taller ones. But then everybody else kept going, and when we came back for 7th grade basketball, that was not the case anymore. So I went from being a power forward to a sit over here, guard, and we'll let you know when it's your turn. So yeah, that was a lot of fun. But anyway, enough about me. Let's talk more about mitosis. But what I was saying is that through these development years, with your skin and your organs and everything, those are all still growing. So they've got to develop at such a pace to where not only are they replacing dead cells, but you need more cells as you develop. So if you're growing, like there was a period of time with my son to where we couldn't keep a pair of shoes on him. It seemed like every 2 or 3 weeks, hey, my shoes are too tight. Really? Well, we just got those like yesterday. Sorry, they don't fit anymore. So because his foot was getting longer, so got that new cells. You got to have all those new cells. So if yesterday's size of foot needed, we'll say 10 million cells, now we need 11 million. Okay, then 12 million. And so not only are they replacing, but they've also got to stay ahead of the growth that's needed to make more. So during your development years, it would stand to reason that this happens at a much faster pace, this whole cell cycle, than someone at my age now, who's all we're trying to do is just replace dead cells and things like that. So, but enough about that. Let's talk mitosis here. So let me get me a little box here, and I'll put this up here. So we are talking suddenly I panicked. There was an extra O in there. Oh yeah, there is at the beginning. I don't need that one at the beginning. That's the one I don't need. Mitosis. Alright, so it starts with prophase. And again, I'll go fancy outline style, little dash there. Now prophase, the first thing that's going on here, or one of the things that's going on, is we're going to finish the folding process. So all those histones that were made that we talked about earlier, scoot this over, and I don't want to cover me up either, so I got to go way over here because I know you don't want to cover that up right there unless you've already got the post-it note over it that we talked about last time. Okay, but we're going to focus and I want to edit it. Yeah, thank you. We're going to finish the folding process. All those new histones that are being made that we talked about, they're finishing that folding process because we've got to get these things as condensed down and tight as we can, because eventually they got to get to this stage right here. So we're finishing that folding process. Remember, we've got 92. Okay, 92 chromosomes. 92 chromosomes because we've got 2 sets in there. Okay, 2 sets in there. And let's see, the nucleus, and I mentioned this earlier. And of course my streak of one time remembering my fancy little line here is over. I have to start us a new streak here. Nucleus is broken down, dissolved, and dash, there we go, back on track. The microtubules, gather up, and that's the microtubules, are these little spider-looking things over here. And we saw those way back in organelles. We did a little talk on microtubules, and I even mentioned at that point in time, hey, those are the things that eventually we're going to see dragging the chromosomes around during mitosis. So I hope you remember that, but that's these guys right over here at the microtubules. Here's a better look at them, and of course they're here as well. And you can kind of see them in here, but now they're dissolving and getting out of the picture. And of course, these little dots here, that's the leftovers from all this anchor spot here. Okay, the microtubules, they start gathering up. They know they're getting ready to go to work. And the microtubules attach. And this is this word that we mentioned this one yesterday. Got it spelled right? Yeah. No, wait, that's supposed to be an O right there. All right, this is the word that we mentioned yesterday, and this is simply, and it's you know what? I think I'm going to go. I can show you over here a little bit easier. Yeah. Okay, this word. Let me get a pen here. So this word right here is this middle section, and let's blow this up here. That's this little middle section right here. There's a little brad there that we talked about yesterday that we saw. It attaches to those. So let's close this back out, zoom back out, move back over here. That's that little brad there. And then we want to edit that since we are not done talking. So that's prophase. And let me go down one more line just to separate. The next one, metaphase. And if you just want a little metaphorical way to try to remember this, prophase, everything's just in a big pile. Okay, everything's just kind of piled up. We're gathering everything. It's all just stacking up. You know, like you would gather all your construction supplies. You're gonna build a house. You're gonna build a table. You're gonna build something. You just kind of get everything, put it in a big pile, and then get to work on it. So prophase, big pile. Metaphase, your metaphorical word there. Metaphase, middle. Okay, all the chromosomes are being lined up in the middle, and that's a pretty cool task. Let me tell you what's going on with metaphase. It isn't just that they line up; they do line up, but how that process occurs is amazing. Okay, I did say chromosomes line up. And I'm going to type it first, and then I'll show you. Okay, the microtubules anchor themselves. And what's going on here, not only do they attach, okay, so if up here this dissolves and they start attaching, and there's one up here that attaches there, and one in here that's going to pull them this way. But it's the idea of they anchor themselves to the poles of this cell wall down here. They anchor themselves to that, and this one anchors itself up to here, and then they are also already attached to that middle section, that kinetochore, right there that we just identified. And you can see that not only is this microtubule attached to all its side of the kinetochores, this one up here is also attached to its kinetochores up there. So essentially we're in preparation of pulling those towards each of the ends to get them away from each other, so when the cell can divide, we've got that. So the I left out an O right there. Hopefully you knew that and put your O there. So the microtubules anchor, and you're just getting everything ready to go. So that's metaphase, and I can already tell eventually I'm going to have to scoot this up. Anaphase. Okay, anaphase is next, and in the anaphase they're pulled apart. So anaphase, apart, metaphase, middle, prophase, pile. Anaphase. Yeah, and I can still see the anaphase picture up there. So anaphase, chromosomes are pulled apart. Okay, and actually, you know what? That's all we got for that one. So they're just pulled down to those, and you can see here they're pulled down to those poles, those edges. And so that's anaphase. Our next section is telophase. And again, we are almost to the end here, so just a few more things here to say. Telophase, you can see here that cleavage furrow, and of course, funny word to type, but that's all right. Cleavage furrow, that's this section right in here, begins to develop. You can see that right there. And in essence, it's just beginning to separate. And when you see this in a plant cell, it's basically a hard line, a hard wall that's fairly thick. And then when it separates, half of that wall goes with the upper half, and the bottom half goes with the bottom half, and that becomes the fourth part of their cell wall. So there you go, a little extra bonus there for you. But the cleavage furrows forms. Okay, and that's the telophase. And then of course one more here, and yep. So E. No, it should have been IN. And one more E right there. Cytokinesis. And just pretty self-explanatory. Cell divides. Okay, the cell divides, and you can see that obviously right there. And they've gone ahead and shown you that the nucleus develops, and the nucleolus is already right there, and so RNA stuff is getting made. Excuse me on that. And let me close this out. And you know what? Let me flip over my note page here just to make sure. Yep, the next note is heredity. So that's the ball game right there. That's the ball game. Man, I hope you liked that. Hope you enjoyed that. Hope you got some good information. And this stuff right here, not only is it fascinating, it's super simple to make a test about, because there's all kinds of multiple choice questions that a person can develop that, or a short answer. But anyway, I love talking about this stuff and super enjoy it. And I hope you enjoyed it as well. Hope you're enjoying your day, whatever day it might be for you. There's such a varying degree of months that different schools are going to watch this. If this is our, excuse me there, the A&P people, you'll be first to see this. Just about 10 days, I think, is when you guys will be scheduled for this kind of stuff. But the A&P, the Nevada High School people, it's going to be months from now. Because if this is, let's see, chapters 1, 2, 3, 4 was organelles. If we do this as our 5th unit, that's over halfway. So we're deep into the January, February kind of time period. So that's way on down the road. But hey, enjoy the rest of your day, whatever's going on. Man, I hope you're safe and secure, and your family is solid and everything with the virus and everything. Can't wait to see how this all unfolds. Either it's just going to be of course, I'm making this early September, and so when most of you watch this, the school year is unfolded pretty far. But just hope everything works out. And if this is a new normal with masks and gloves and everything, that's fine. Love what I'm doing. If we ever go back to the more open way, that's fine too. But hey, just appreciate everybody. Love you guys, and look forward to talking to you in class again. And with that, everybody, we will say goodbye.